Okay, in this example we're looking at the limit of a function. It's an example of a limit. So the function is x squared plus 1, and we're asking the question, what is the limit as x approaches 2 of x squared plus 1? So the question is basically this expression, what does it get close to when the value of x we put in gets close to 2? Okay, so a couple of ways of doing this. We're going to look at two ways of doing this in this example, computing the limit. Okay, so first of all is the graph. You can often find limits by just looking at the graph. Because what this is really, what this graph is of, in fact, is the function y equals x squared plus 1. Okay, so what happens to this function when x gets close to 2? Well, 2 is right here on the x-axis. So to answer this question graphically, what we have to do is look at the graph and say, what y value is the graph getting close to when the x value gets close to 2? Now, sometimes this is the same thing as the exact y value we get out when we put 2 in for x. And in this case it will be. But again, the question is, what does the y value get close to when x gets close to 2? So to look at the graph, here's kind of what you think about. You think about the number 2, and what happens when we put x values that are getting closer to 2 into the graph? Okay, well, we can see that if I put, for instance, this x value into the function, I get a y value out right around here. Okay, if I put a number in even closer to 2, I get a y value out around here. Okay. And if I put numbers that are really, really close to 2, I should get something out very, very close to about this number. Okay, because that's what the graph is approaching when I get close to 2 from the left side. Okay. Now when I get close to 2 from the right side, when I think about putting these x coordinates into the function, I get y values out that are a little bit bigger. For instance, if I put this number in, what is that, about 2.5? If I put that into the function, I get a y value up here. Okay. If I put a number a little bit closer to 2 from the right side, get something out about here, and when I get really, really close to 2, the y value is getting really close to this y value right here. Okay. Now notice we can answer this question without actually looking at the y value when x is 2. Okay. The y value could actually be anything we want here. There could even be no y value. But certainly when x gets close to 2, the y value is getting close to this point right here, which happens to be 5. Okay. Now another way to answer this question, probably a little bit easier to do, it's a calculation but it doesn't involve graphing, is to make a table. Okay. So what you see here are actually two tables that really just answer that question through example. Okay, so here, what do I have in each table here? Well, I have some numbers for x, which are close to 2. In fact, they're getting closer and closer to 2. This is 1.9. Okay, this is 1.99 and 1.999. So the idea here is let's put a couple of numbers that are getting close to 2, closer to 2, in for x and see what we get out for y. Okay. Well, since this is the function, x squared plus 1, I can just put these numbers into the calculator and compute y. And what you'll see is that as I put these numbers in for x, which are getting closer to 2, the y value I get out is, well, what is it? It's 4.61. Okay, then it's 4.96 and 4.996, which is, of course, getting really close to 5. Okay. Now, I also have to look on the other side of 2. These are numbers which are close to 2, but to the left of 2. They're a little bit smaller than 2. Okay, these numbers are getting closer to 2 for x, but from the right side. 2.1 is a little bigger than 2. 2.01 is just a tiny bit bigger than 2. And 2.001 is just a very small amount bigger than 2. But as I put these numbers in for x, which are getting closer to 2, now from the right side, I see that the y value I get out is, again, getting close to 5. Now it starts a little bit bigger than 5 and gradually gets closer and closer. Okay. So that corroborates the story I got from the graph, that in both cases, as x gets close to 2, the y value seems to get close to 5. So we can say that this limit is 5.